Hey everybody, the purpose of this video is to get you some solutions to the linear regression quiz on Facebook. Facebook privacy policies. Here's your data set, the years and the number of words in Facebook's privacy policy. I ask you to run a linear regression on this guy. It looks like I ask you to let this be 0, 1, 2. Watch this one. This one skips to 4 and 5. So this is what you're going to be putting into L1 as far as your data goes in L1. And here's L2. Right, this guy right here. So that's for starters. And then you just run through your little booklet to get your linear regression all taken care of. You can make a scatter plot. It's almost perfectly linear. The model ends up being y equals 983x plus 1,162. And I've got the variables defined for you there. X is number of years since 2005, and Y is the number of words in the privacy policy. So far, so good. Interpret the slope in a model. This is the first question you have to do for points. It's all about this 983 right here. It's all about that. And what does that tell you? Well, that gives you the rate of change in the line. So on average, Facebook is adding 983 words to its privacy policy every year. On average, every year, Facebook picks up 983 words from its privacy policy, or adds 983 words to its privacy policy. That's all I'm looking for. It says, according to this model, how many words should have been in Facebook's policy in 2008? Well, we skipped over 2008 to get from 7 to 9, which means we're going to have to run 3 through the model. 2008 is x equals 3. So there's a couple ways you can do this. You can run 3 into the equation right there, or you can use your table or your grapher on your TI. Doesn't matter how you do it. However you do it, it ends up being about 4,112. If you use that program that I gave you guys called regconf, it gives you a range of values from 3,300 to 4,920, which makes perfect sense. It's directly between these two values, and it surrounds these two values in something called a confidence interval, although it might be too wide to be useful. I mean, you're talking about going out 800 words on either side of that. But anyway, if you just simply run the number in, 4,112, you're good to go. In which year will Facebook have more than 10,000 words? So in that one, you want to let y equal 10,000, and then solve that for x. And again, 2 ways you can do it, like we did in class. You can crank it algebraically, like we did in the Mount Bachelor example and or the insurance example. Or you can just run it a y1, y2 type thing. Either way, it's going to be around 2014, because when y is about 10,000, x is about 9, which corresponds to the year 2014, because it's 9 years after 2005. 9 years after 2005. So we're going outside the data set, which actually answers the next question. Which of the questions asks you to extrapolate? That's the one previous, the one we just did, because you're extrapolating outside of the data set. 10,000 is outside of 5830, and 9 is outside of 5. Name one reasoning that extrapolation with any data set can lead to inaccurate conclusions. The biggest problem with extrapolation, the absolute largest problem with extrapolation, is the fact that you're assuming that whatever data pattern exists from 2005 to 2010, i.e. this one, i.e. that one, you're assuming that is going to continue into the future, and there's no guarantee that's going to continue into the future. For example, if Facebook itself decides that these 5,800 words get everything across that need to get across, why would they keep adding 1,000 words a year? There's no reason to, unless they just like to be verbose, which seems, again, kind of counter to what Facebook is all about. So the idea really is, quite simply, that you can't assume that your past behavior is going to be indicative of what's going to happen in the future. Now, some of that can be mitigated by setting up a margin of error around your values. So you can instead of saying, for example, this is 4112, you can say it's 3,300 up to 4,920. Instead of saying in 2014 it's going to be 10,000, you can say in 2014 it's from 9,000 to 11,000. And that gets you a range of values, which is great. But the problem with that still is that the underlying assumption is that it's behaving linearly. It's less dangerous than simply giving one value, but it's not any less dangerous than saying, let's take a time out. Can we collect more data? Can we get 2011, 12, and 13 at this point and see how they shook out with these? So the further you get from your data set, the more potentially dangerous you're going to have of a time of trying to justify the extrapolation. Cool. Hope that helped, and we'll see you in class.